So in this video, I'm going to try and measure the time period of oscillations of a simple pendulum. The pendulum is this bob here and a length of string that's about 33.5 centimeters long. And it's oscillating between a light source, an LED connected to SQ1, which is just on, and a phototransistor, which is connected to between sen and ground. So the collector of the phototransistor is at sen and the emitter is grounded. Now, whenever this bob intersects this beam, the signal on sen changes. So the voltage level is typically low when there's light incident on the phototransistor, and when the light path is blocked, the signal level goes high. So let's look at these signals in the pendulum time period measurement experiment. And as you can see with this graph, the signal oscillates between low and high. Right now, what we want to do is measure the time period. So now the time period of one full oscillation is when it intersects for the first time, and then you ignore the return path. And when the pendulum intersects for a second time coming from one direction, that's your time for one full oscillation. So you see, I've got 1.167 seconds. Now let's take a few readings just to be sure that it's repeatable. Okay, 1.167, 1.167. So we're getting very repeatable values within a millisecond of error. And this time period, you can also take n number of points by going to the record data tab and then saying, okay, I want to continuously measure and just verify that it's a flat line and that the time period of the pendulum is not changing, which it shouldn't for small oscillations, small angle oscillations. Let's go back here. I'll just stop this. I'll go back here. Now we need to use this particular value 1.166, 1.167 and verify that this is the correct time period. So if I'm going to use the math library, and our time period is t is 1.167, okay, and the equation for the time period is 2 pi under root L by G. So I'm going to put G as 980 centimeters per second square. L I wish to calculate, and T I have already calculated. So this is square root. So now if I invert this equation to find out what the length of the pendulum is here. So this 980 centimeters per second square into time upon 2 pi whole square. And yeah, so the length that I'm getting, 33.8, is very close to the 33.5 centimeter length of this simple pendulum.